Hello there. Welcome to task 3. The task 3 is design and develop a flowchart and algorithm. Okay, we will also put algorithm. We are not doing flowcharts. Flowcharts you people can try. Flowchart or algorithm to find the square root of a number. To find the square root of that number. Okay. Any given number, and then implement a C program for the same and execute all possible inputs with appropriate messages. Okay, and they have clearly said that we are not supposed to use the library functions. We will use the library functions to compare our results. Okay, just to see whether our results are coinciding with the built-in function results. Once that happens, then we know that our algorithm is working correctly or working perfectly. Alright, so now what we will do is we will now look at, as usual, typical bookkeeping which we tried earlier. Okay, so we'll try and look at the typical bookkeeping. Since they have not asked to use the square root function, we'll try and look at this concept. Right now, we have to do bookkeeping before we write an algorithm. So this is a very good practice. So what does it says? We all know that if you look at the definition of a square root of a number, the square root of a number is that number whose square gives the same number. For example, if I take 25, the square root of 25 is say 5, and square of 5 is 25. So square roots of a number can be a perfect square or an approximated number, or an approximation you can say. Means what? For example, if I take square root of 4, it is 2. 2 square is 4. But we will have issues when I take, for example, if it is not a perfect number. Now suppose the square root of 2 is something dash 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 whose square is 2. So this is where our logic comes. So this we have to approximate and see how do I get the square root of 2. One thing is the answer lies in the explanation itself, which means my square root will typically start from what is called, sorry for that phone call. So square root of 2 is an approximation whose square should be 2. So we know that our logic should be like this: the square root of root of a number is lying between 0 and that number. Now what does that mean? For example, if I say square root of say 7, so my square root of 7 is lying between 0 and 7. It can't be greater than 7 because squaring that number will be greater than 7. Okay, so which means that you may again ask me why the number lies between 0 and 7, because the square root of a non-negative number can only be found out. You can't find out the square root of a negative number. Okay, so that is the reason it is always from 0 and above. Now our question is, how do I reach to 7 from 0? So I need to decide something called steps of approximation. So let me call it as a delta. So I will increment delta from m equal to 0 to 7 or I can say I will increment m from m equal to 0 to 7 in steps of delta. So if my m square, as long as my m square remains less than 7, I keep on incrementing. The moment my m square becomes greater than 7, we stop, and then my square root will be final value of m minus delta. Now you may ask me why I have taken minus delta, because that plus delta made my m square to go beyond 7. So I will deduct it. So it will be either exactly on 7 or it will be somewhere, okay, the value of m square will be exactly on 7 or somewhere between 6.9999, because we have to give an approximation to delta. Alright. So I hope you understood this logic. If you have not understood this logic, please go back, rewind and understand this concept. In fact, there are other methods to find square root of a number as well. So there is one more method called Newton-Raphson method. To calculate the square root. Which is out of the scope of this program, because since it is the first year computer lab program, we will try and look at the simple approximation method. As long as we are not using the built-in library function, it does not matter what method you follow. Okay, so now let us start developing an algorithm for finding the square root of a number. So what do? I will take the square root algorithm for square root of a number. Algorithm for finding the square root of a number. So what is my step? My step 1 is, so I will say start. My step 2 is accept the number I call it as the number, then set approximation delta, set approximation delta equal to 0.00001. You can go up to anything that you want. While so before that, while m square remains less than the number, m square remains less than that number. So why my m square remains less than number, I perform step 5 through before that. I will also set my m is equal to 0. So what I will do is, in my step 6, I will do m is equal to m plus delta. Okay, the moment it comes out, so step 5 through step 6, in my step 7, the square root of, I will print the square root, the square root of the number will be m minus delta. Okay, then I will stop. Okay, so hope that this will work. For example, if my number is say 9, correct? So I'll set the delta to 0.001. It will start from m. So my 0 square is less than 9. So it performs, I keep on adding. So I may go up to say 3.01. My 3.01 will become greater than 9. 3.001 will get greater than 9. So then I will stop there, because this condition stops. Then I will subtract m minus delta, which is nothing but the square root of the number. Alright, so this is the algorithm for a square root of a number. Let us see if the algorithm, we can make it work, convert that into a program. So for a program, what I do is, as usual, include stdio.h. Okay, stdio.h. So first I will take the number, which will be my double number. Then I will take my double, which is my delta, which I will assign it as 0.0001. Then I'll also take my double m. I will not assign the value of m and num as 0 because it is a global variable, so we will not have any issue. I will say int main. So what I will do is, as usual, I will say printf, enter the value of n, okay, which is nothing but the number. Scanf, we already know from the previous lectures, percentage %lf, and of num. Okay, so now what we will do is, while our number, while our m into m remain less than the number, we will only say m is equal to m plus delta. Okay, so I think you must have got this logic by now. Then we'll just to see whether this concept is going to work, we'll simply say program halted at the value of m equal to percentage %lf m. We'll just see where it exactly halts, or does it actually halt. Right, so let us save this code and compile this code. So we have no errors, luckily. I'll say, let me make it as 9. The program halted at 3, which clearly means that we are able to find out the square root of a number perfectly. Okay, now let me take one more. So if I take 2, it is 141220, isn't it? So but what we will do is, since it is giving this perfectly, we will just try and give few more zeros for our approximation, and then we will try and compile this and we'll do the OP. So now if I say 2, I still get the value program halted at, so which means that now once it is halted at, now what I will do is, I will simply say printf the square root of a given number percentage %lf is percentage %lf, which is nothing but my num, and next one is my m, minus delta, if at all. It may not make any difference, but still we may get a perfect approximation value. Now we will also compare with our built-in function. Okay, the square root of a number, given number so and so, using built-in function is, so here we will simply say num and square root of num. Okay, see, again they have said do not use. We are using only to compare, we are actually not using to calculate. Alright, so then we will include math.h. Okay, we will save this code and let us see if there are any syntax errors to begin with. Okay, so we have delta was not declared, that was because I have made it's a capital delta. Okay, we will save this code, rerun this, so we have no errors. Output, so let me give the square root of is 2. Okay, so the we have got 141213. The built-in function has given 1.2214. So that is, we are perfect. We are perfectly, our answer is perfect. So we are able to get the square root number without using the built-in function, and we are using the built-in function only to compare with our results. Okay, so to get a proper output, so our program is working correctly. Let me take 144 for example. Okay, so the square root of that is 12, this is also 12. So for perfect square we are actually getting the correct, okay, answers, right? I've just done some changes for the output to look better. So let me take 343, which is 18.52, so that is also 18.5, almost 52059. All right, so this is what we mean by square root of a number without using the built-in function. Again, I am telling you, we are using the built-in function only to compare our results. Hope you understood this, remaining in the subsequent lectures. Thank you very much.